Hello, welcome to another edition of House Modeling Tutorial. Let's build a water tower for this building. So we need to find some space somewhere for our water tower to fit, and it should have a dimension of about 5 feet by 5 feet minimum. Let's see if we can. Let's try 5.5 by 5.5. Yes, I wanted to check if it would fit into this spot, and I think it fits in nicely. So let's say we had a height of about 25 meters, 25 feet. Let's see what it would look like. Camera 2. Yeah, so our water tower would be somewhere here, placed here. Let's see if it would work here too. Yes, it could, but because there's a balcony, and let's take it right back here. So we want our water tower placed here, and we're going to, I beg your pardon, we're going to assume that the water tower would be built with heavy gauge steel, and let's get on with it. Now, in Nigeria, it's quite common for you to use 3-inch in diameter gauge steel, cylindrical, and so let's start with that. I want it to be, let me press the hell, because the water tower would serve the top floor too, it has to be taller than, say, this level. So this is 25 feet. I think it can be lower. Let's try and see what 22 feet would look like. 22, yes, 22 is okay. So our water tower could be this tall. This is from here to this place is 22 feet, and that's okay. So we are going to build a 22-foot tall water tower. So we can, okay, I'm going to turn the height of this cylinder, the height here, to 22 feet. Slide sides would be, say, 60 to make it rounder. Before it was 60, it was 18. Let me show you what 18 looked like. One moment. Yes, you can see jagged edges. So when I come here and I type 60, the edges are smoother. So that's okay. Now, the diameter of the pipe, which is quite common in Nigeria for water towers, the diameter is 3 inches. So 3 inches would be 0.25 feet. That's a quarter of a foot, because a foot is 12 inches. So now here we have radius. This is the radius. Radius is half of the diameter. That means from this center to the edge. And that's supposed to be half of 3 inches, which would be 1.5 inches. Now, here to here is the diameter. So here to here would be the radius. Now, the radius would be, if the diameter is 0.25 feet, which is 3 inches, then the radius would be 0.125 feet. That's it. That's what a 3-inch steel pipe would look like. Now let's place it here. Then another one. You hold shift down and you drag, and it creates a clone for you. I beg your pardon. Yes. Then I can select, okay. Yeah, there's two. And I drag them down here. And I can delete this. So let's see what we have. You can see these are the 4 legs of the water tower. These are the 4 legs of the water tower. So let me just apply a material to them. So because I'm still going to replicate them to create the what's the word now? The structural members, the members that would intersect one another. So let me just create material for. Let me give it a name here. 21 default would be changed to say water tower silver. Most people would paint silver on black in this part of the world. So let's try silver. That's what we have. Corona physical material. Color. No, let's come here. Let's look for a preset. I like aluminium brushed. Personally, I like how it looks. So I don't think I really want to. Roughness 0.4. Let's take that up a notch. 0.6, yes. Then I apply it here. I apply here. I apply here. And I apply here. So let's see. If we take away the edge faces, yes. So that's the silver color. I'm zooming in so we all can see what we have achieved so far. So those are the 4 legs of the water tower. So let's give it a foundation at the base, a concrete foundation. Now, if the water tower is 4.5 feet, in most cases, this would not show. By the time you floor your house, this would not be visible. So I think it's safe to take it away. Let's take it away. So let's just work on the structural members. So I'm going to duplicate this. Sorry about that. So let's make the height of this say 5.5 feet, or yeah, 5.5 feet. 5.5 feet. Enter. Then I'm going to rotate it. Come to here, say 90. Yes. And then I bring it here. Then I move it in. This comes with practice. Before you will design this, you most likely would be familiar with the size. I mean, when I say 3 inches, it was because I had measured it before. I have one in my house presently. I've measured it. I know what the thickness of the pipe, sorry, what the diameter of the pipe is. So if you were to design this for a client, you would have intimated yourself with these things. You would have seen them all around you and known, okay, this appears to be the size that they come in, right? You don't just come up with an arbitrary figure. And so when you're designing a space, you realize that I had to check if this space would fit a water tower. And if it wouldn't, then I would have to move the house, say, to the right to create more space. Now, this way, that means someone coming like this can move this way and still go to the back of the house. I'm just duplicating the 5.5 foot tall cylinder, that's all. That's just what I'm doing here. It's no biggie, it's nothing. So let's see what we have so far. There they are down there. 1, 2, 3, 4. So I'm going to take the 4 of them, group, then F, move them up a little, another one here, another one here, and say another one here. Let's move this down a little. So let's see what we have. You can see it's looking like a water tower. this alone would not stop crosswinds. It would not stop winds from bringing this down. You still have to add diagonal bracing. These are just horizontal bracings. They will not keep this from falling. So let's work on the vertical, on the horizontal bracing. You know what? Let's just do this, 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 this. And hide on selected. So you see, now we're working with this only. So let's take, yeah, one leg. Okay. Let's call it, let's give it height of 7 feet. Yes, there it is. Let's rotate it. Yeah, something like that. And bring it here. So now I can right click, editable poly. No, this won't work. I have to, yeah, okay. Yeah, it's your work. I just have to bring this in. Yes. And let me see where it is. Okay, yes. So I want another one. Let's go to top view. Let's rotate it 90 degrees. No, before we rotate it, let's just take another one to this side. It looks horizontal. It's not, it's a diagonal. You can see now we have two diagonals. So let's duplicate again, shift and drag. Let's rotate this 90 degrees on the z-axis, and let's move this here. We have to move this inwards a bit. Okay, I have to press the hell button. Yes. Okay, so now I can move it inwards. Yes. Let's see what it looks like. And it's not tidy. Bring it here. Many people, I've seen structural engineers say that it's better to use a square. All right, it works better, prevents is it torsional? I think it's much more torsional rigid. I apologize if I'm using the wrong term here, right? Compared to a cylindrical pipe, but in Africa, what we use largely are cylindrical pipes for our water towers. So you can see now we have one diagonal, two diagonal, three diagonals, four diagonals. So I'm going to group all the diagonals. Group. Yeah. Then I do hef. Then I bring them down. Okay. Then I bring them down. Okay. Nah, I don't need that. The base. Based on experience, based on the ones I've seen. And there you have it. That's a water tower. But we're not done yet. Say you wanted your tower to be able to fit in, to have two tanks. Then let's do that. Let me take this, group this, ungroup this, I'll select this, then I'll move this way. One, let's say 7. Yes. So let's group this. This going to support the tanks. Then I come here. I'm duplicating again, shift and drag. They're all made with, so far we've only been working with 3-inch pipes. You can see 3-inch pipes only so far. as a water tower. Now we have to create a staircase. Oh, sorry, ladder. So let's come here, and instead of 1 inch, 3 inch pipe, let's do say a pipe that has a diameter of 0. Let's do 1.5 inch pipe. Okay, so let's do cylinder here. So 1.5 inches would be 0.125. So divided by 2, the radius would be 0.062. Yeah, something like that. The height will be 22. F. There it is. Yes. So F. Now I'm going to take this one, vertices. I'm going to delete this, and I'm going to move this here. I want to see what I'm achieving by doing that. Do I like it? It's going to compromise this stand. Okay, so I'm going to leave that as it is. Yes, it's right back where it was. So let's give this a color, the same color, which is this one, water tower silver. So yes, you could jolly well just use a 3 inch pipe to do it. All right, but most of the ones I have seen here, they often this particular ladder is made slimmer. So now let's take the same pipe. Let's take it this way. I'm duplicating it. Let's make the height say 1 foot. Let's rotate it 90 degrees. No, not 90 that way. 90 this way, yes. And then let's bring it here. Let's make the height here. I'm coming here. I'm right here. Let's say 1.5, 1.5. Yes, this should be okay. So I'm going to move this on the z-axis. Yes. So now we're ready to create our ladder. Let's put a space of about 14 inches in between them. Each height. Calculator. What would 14 inches be in foot? Let's see. 14 inches divided by 12 is equal to 1.16. So this is how I do it. I would draw a box now, and I would give the length of the box 1.16. Yes, this is a 1.16 box. Yes, it's right here. It has converted it to fractional inches, but if it were decimal inches, what you would see here in the length would be 1.16. Now I take this guy, I hold shift down, and I drag up to this point. Then it asks me, do you want to duplicate? And I say yes. Say click create 18 pieces, 18 versions of it. Good. And then it takes it all the way up. You can see all the way up. Then I can delete this guy. So what do we have? That's it. That's the ladder. That's the ladder. So I can see my 18 inches extended way above. I think I'm going to need this one. So let's just delete this. Delete this. Yeah, that's all. Now this one, should we use this? Yes, we could use this. We want to create horizontal bracing at this point to protect the plumber. So I take this guy and I go this way. You can see. Yep. So this is just to protect whoever would be climbing. So there it is. Then I take another one. I'm duplicating now. Another one will be here. Yes. But right now I am using a 1.5 inch pipe. 90 degrees. Gonna move it. This two should touch one another. Yes. Vertex, this would go in. Yes. And so now you have horizontal bracing, you can see. But now one thing I didn't do is I have to create a space here so that whoever is climbing will have access. So sorry, I'll take this one and I'm going to move the vertices inwards like this. Now you may not see what I have done, but when I go to the camera view, now I have created a vacuum here. So whoever is climbing can come in through here. If I were to no, if I Control Z, you would see originally this extended to this point. Now by dragging the vertices to the left, I have created this vacuum. Now this particular rung of the ladder, I'm going to take it out. Yes, you can see. So he climbs this, then he lands here. That's that. Then another thing, these are 3-inch pipes, quite alright, but the vacuum here, the spaces in between them could, and I've seen it happen many times. Often, because of the pressure, water has a much higher pressure at the bottom of whatever container compared to the top. It will want to force the bottom of the tank, of the plastic tank, to conform to these. It's going to have a hard time doing it, but with time, because of the sun and the rain hitting the tank, the plastic tank, it will eventually take a slightly deformed shape at the bottom. This eventually causes leaks. So what most people do is they install a plate here. The plate would be, say, 1/8 of an inch thick, and that would be 0.01. Let's move it upwards. We're bringing it upwards. It's coming up. You can't really see it, but it's there. There it is. So you would install it on this one. It could have the same color, the same silver color. Yes. So this is what it looks like. You can see. So vertex, editable poly. Let's do change the drag this here. Some people don't let it cover fully, but I think it's better. It makes it safer for the plumber to walk on it without the fear of having his leg caught in between the cylindrical pipes. So that's what the plate often looks like. So there's your plate. Now we need another one down here. There it is, tiny. And then you drop it here. So let's see what we have. That's your water tower. That's the water tower. Oh, sorry. This should not be here. It's coming downwards. I apologize. F. Yes, it's coming here. You can see. Now, another thing I've not considered, which is part of a building code, when you're making balustrades, it's often recommended that your balustrade should not be less than 3 feet tall, and sorry, shouldn't be less than three. Should not be less than 3 feet tall, but 3.5 feet, which is 42 inches, is often recommended. Now, what am I trying to do? The job of a balustrade is when you're on a platform, say a balcony or on a staircase, it prevents you from falling. And the recommended height is 3 feet, not less than 3 feet, but 3.5 feet is often recommended. Now, what does that mean for the water tower? This supports at the top, they should be the same height, 3.5 feet tall, so that whenever someone is standing here, it's quite comfortable that it's not going to trip over, it's not going to fall over to his death. So, how do we achieve that? From this platform here, we are going to create a 3.5 foot box. So it's like this. Let it rest on this platform. Another person wouldn't do it like this, but this works for me, so that's just what I do. Then everything here, let me freeze this. Hide freeze selection. Yes, then everything here, I'm going to move it upwards. You can see what I've done. So everything here, let me just group it so I can group. Yeah, so now I can unfreeze all and delete this. Then I take these pipes, convert them to editable poly, then I drag the top to touch this. You can see I take this editable poly, yes, this is the front view. Let's do back view. There should be another pipe here. Yes, convert to editable poly, take the vertices at the top. Yep, there's one pipe here. Right click, editable poly. Yeah, so we're left with this. Right click, editable poly, vertices, drag them upwards. Now let's see what it looks like. You can see. So now we're going to use 1.5 foot pipes to create brazens. So let's take, say we take one of the rungs, F. Let's take one of the rungs, hold shift down, it clones it. Let's right click it and say, let's put 0 here. Yes, good. And let's call it height. We're changing this height. The height originally was 1.5. So let's change it to 3.5. Good. And let's bring it here. Good. So 2. Yes. So let's take another one. No. Let me try from the top view. Yes. Put another one here. Now let's go to the left view. Yes, then say 4. Yes, try take all the 4. This way, group them. Then hold shift down this way. Then hold shift down, say let's say here first. Then let's rotate this on the z-axis by 90 degrees, and I think we're taking that here. To be sure we have it where it should be, let's change the top view to the back view. Yes, something like this. So let's see what we have. So that's your water tower. You can climb up, and when you're done, you can work there, and it's safe. There is your water tower. Now we can unhide all, and then you see the water tower. There it is. I like it, it's beautiful. I don't want it to be too long. I think I'm going to have to draw the water tank in another video. I think you see it. Yeah. Let me see if I can render. Um, see its render. If you the building codes that you can check, they'll tell you how deep your water tower should be, what the foundation, how deep the foundation of your water tower should be before it can stand the stall. I honestly would think the ratio should be about 1:7, which means the um, the height of the water tower altogether, which means from your ground level to the very top, divided by 7. I don't know the actual values, but for this one, if I were to divide by 7, I think this was originally 22 somewhere here. It was 22 somewhere here. Now we are at 3.5, so you now have about 25 and a half. But when you divide that by 7, I think you have less than 4. You have divided by 7. Nah, it's less than 4. No, that's not good. Let's divide by 6, 4. But I'm sure there's a way to calculate it. But if you were to what's the word I'm looking for now? It's not coming. If you check engineering codes, if you check building codes, you get the foundation dimensions, how deep the foundation of a water tower should be. You don't necessarily have to connect it to the building. You don't have to. If you make it plumb, all right, if you make it plumb and the foundation is deep, it will stand on its own. And with this bracing, it will resist winds from all directions. It will. So with this, you can have a tank here, you can have a tank here. I'm not sure if the distance from here to here, all right, is more than 6 feet. Ideally, it should be, say, 8 feet, 9 feet, so that there's enough room for the plumber to work. All right. So if I find out later that it's not enough, I'll have to drag all this downwards a bit, which is doable. Then this can also be tidied up, because when instead of bringing this diagonal bracing downwards here, it will come this way and stop somewhere here. So whoever wants to climb the ladder will not be hindered in any way. I can always tidy that up later, or if you do following this tutorial and you would like to draw something like that, you can do that. You just have to take the vertices here and push them upwards and leftwards or rightwards till they fall somewhere here, so that there will be a free flow from the top here downwards. But that's how you draw a water tower. in case you have questions, you can send me a message. I'll be happy to respond. Sorry. Hopefully, in the next tutorial, I'll draw the tank and PVC piping. Alright, just simulate that just for you to see where the pipe would be. You don't necessarily have to do that. Alright, if you were designing for a client, the client would not need that many details. Alright, just put the tank here, put the tank there, and then go on to something else. Alright. But if there is time, I might introduce the PVC piping. If there isn't, I'm just going to drop the tanks and drop the tanks there so that we can move on to something else. I hope you understand. This has been fun. Thank you so much, and I'll see you next time.